We have studied vector addition, subtraction, and two types of vector multiplication, namely the dot product and the vector product, but we have never studied vector division. Does that mean that vector division isn't possible? Let's check it out. First, we know that a vector can be represented by a column matrix with the elements of that column matrix being given by the components of that vector along the three mutually perpendicular directions x, y, and z axis in Cartesian space. As you can see here, I have taken a vector A is equal to 2i plus 3j plus 4k, which can also be represented as the column matrix 2, 3, and 4, where 2, 3, and 4 are the components of this vector A along x, y, and z axis. Here I, j, and k are the unit vectors along x, y, and z axis respectively. So from now onwards, I will not differentiate between a vector in Cartesian space and a column matrix. So in order to define the division of two vectors or two column matrices, I have taken two column matrices A and C, and the division of the column matrices A and C has been denoted by the matrix B. B is equal to A divided by C. So the relation between A, B, and C can be written something like this. A is equal to B into C. Here B can be considered to be the ratio or the division of column matrices A and C. Now let's suppose the column matrix A is equal to A, B, C, and the column matrix C is equal to D, E, F. Our task is to determine the division matrix of the given column matrices A and C. Here A, B, C, and D, E, F are all given. They are all known. Now stop a minute and let's first check the order of the matrix B. Well, that's easy to see. According to the rules of matrix multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. And also the order of the product matrix is equal to the number of rows of the first matrix cross the number of columns of the second matrix. Using these things, we can easily see that the matrix B is a 3 cross 3 matrix. So let's suppose the matrix B is equal to x1, x2, x3, y1, y2, y3, and z1, z2, z3. Now, after multiplying the two matrices on the right hand side and then comparing the corresponding elements, we get these three equations 1, 2, and 3. Now, here we have 9 unknowns x1, x2, x3, y1, y2, y3, and z1, z2, z3. And we have just three equations to solve these 9 unknowns. Now we know that we can solve these three equations for a unique solution of 9 unknowns because for a unique solution of 9 unknowns we require 9 equations. For a unique solution, only 3 unknowns can be determined from these three equations. Okay, so we have to choose 6 unknowns arbitrarily, and after putting the chosen values of 6 unknowns in equations 1, 2, and 3, we can solve these three equations for the remaining 3 unknowns. To understand it better, let's take an example. Here we have the two column matrices 1, 0, 0 on the left hand side and 0, 0, 1 on the right hand side, and their division is represented by the intervening 3 cross 3 matrix A, B1, C, D0, and E, F0. We can easily see that the two matrices on the RHS on the right hand side can be multiplied to get the column matrix on the left hand side for any arbitrary values of the 6 constants A, B, C, D, E, and F. Whatever the values you choose for these constants a, b, c, d, and f, the equation here would be satisfied. This means that the matrix a, b, 1, c, d, 0, e, f, 0 represents the division of column matrices 1, 0, 0 and 0, 0, 1 for any arbitrary values of a, b, c, d, e, and f. The result of all this manipulation is that the division of two column matrices is not unique. Or in other words, as we know that the vectors are represented as the column matrices, so we can say that the division of two vectors is not unique. And that's the reason vector division is not possible, because after all, the division of two vectors cannot be an arbitrary mathematical object. It must be unique. In conclusion, the division of two vectors or two column matrices is not unique, so vector division and the matrix division is not possible.